there was a theme
Okay.
this year.
Okay.
It was robots and robotic hands.
Hello, everyone, and a happy new year. I am Ben Bajarin. Welcome to another episode of The Circuit.
Happy New Year, programs. I'm Jay Goldberg.
All right, a lot of stuff to talk about relative to CES, but I want to say two things off the bat. One, Ben had a milestone on Twitter. This is very random, which is why I want to talk about it. I had my first tweet go over 1 million views.
Ooh.
And it didn't just do 1 million views. It is now at 3.6 million views. Now, just to prove that you never know it's going to go viral, right? I took pictures of the Vera Rubin rack before anybody because I was one of the few who went up because I did a pregame session with John Fort via CNBC to the NVIDIA keynote. That one is not the one, Jay, that did 1 million views. This last year was one of the first to post pictures of the iPhone Air in my hand. That did like 800K. I took a picture, Jay, of HP's keyboard that has a computer built into it.
Yeah.
And that's the one that went to 3.6 now and counting million views. A keyboard computer, which again, I'm not saying is not interesting. It's the Commodore all over before, right? No screen. But that's not the one that I thought of everything I tweeted. Like I was trying. I was like, here's a picture of the Vera Rubin rack. Like everything. Nothing went as close to viral as this HP running an AMD Ryzen processor keyboard computer. Okay.
Twitter, the gods of Twitter are fickle. I will say though, I saw that in one of the previews videos that HP keyboard, computer and a keyboard. I thought it was pretty cool.
Yeah, no, geeks unite. Like it's great, right? And for a lot of enterprise use cases, I'm not going to say consumer. Yes, it could be an all-in-one, but when you look at what enterprises do, it's like the Nook. But anyway, I'm just saying, like that is not the one I thought was gonna go public. All right, let's go.
Wait, before that, I got one too because I want to say this at the outset. You know how every year you go to CES and you come back and you talk to people who didn't go to CES and may not be in the industry, and they're like, "Oh, you're at CES. What was the theme? What did you see? What was the theme of this show this year?" And every year, I think we've done this. We've had this conversation before in the past. We're like, "There is no theme. It's 50 billion things going on at once. It's everything." But this year, I think there was a theme, right? And I preface it because I think it's a pretty strong statement for me. There was a theme this year.
Okay.
It was robots and robotic hands.
Yes. Agreed. And as a matter of fact, the robots were the singular thing I was out to hunt because last year I almost got punched in the stomach by a robot. So this was like, can we shake hands or do other things where the robot might not accidentally attack me because it does not know, where my hand is versus apparently my gut. So yes, enjoyable. Robots, correct though. Hands, arms, everything. Heads. There was a random amount of robots.
A lot of robots this year.
Lot of robots. All right, let's go through the happenings. We're sort of gonna span the gamut, I guess, because there was obviously AI infrastructure stuff where NVIDIA, AMD had keynotes and talked a lot about next generation AI infrastructure. There was some client announcements, largely, Intel's coming out show for Panther Lake, and kind of a lot of stuff in between. I had some meetings. I can't talk about all of them, but I can share some things within the supply chain and ecosystem, as I'm sure you did too. So let's start, with everybody's favorite, NVIDIA. I was at that keynote, spent some times afterwards catching up with some of the team. I was at both the financial analyst QA and the industry analyst QA for folks like myself. The latter was not able to be recorded and shared, so unfortunately, but I can share some of the things I thought were interesting from Ben's memory. I don't think I think people were happy to see Vera Rubin kind of announced at the show. I personally did not think that was going to happen. I thought that was a GTC event that comes out in March. So now you're kind of like, what are they going to announce at GTC when everybody's, the details around Vera Rubin were amongst the most interesting that we've sort of been waiting for this particular cycle. But a couple things I think were relevant. One, just so we can kind of get it out there in case everybody was confused, NVIDIA is sticking with the NVL72 nomenclature. And by doing so, they are counting now whole dies, not individual GPUs. So if you all remember, right, these are two dies stuck together to make one GPU package. There are, in this case now, 72 GPU packages in Vera Rubin NVL72, but there are in fact 144 die. So that was different than NVL72. I know there was an ultra version of that did go to 144. But anyway, so everybody's not confused. They are not increasing the number of GPUs in a standard configuration. They are just maintaining NVL72 nomenclature. So there's that.
Totally clear.
Yeah, it's not clear.
I'm not confused at all.
It's not clear. I just wanted to get it out there so that at least people, know it is an increase in GPU dies, but that is not going to look like that in the offset. But Rubin looks great. I think there was a number of things. They made the point to come out and say this is the most modular approach, which you kind of had to see the rack to believe it. Basically, instead of wires and kind of having drives and GPUs and whatnot kind of bolted on, it's essentially all compartmentable. So if a GPU essentially goes down, you can just hot swap it basically. So it's much more serviceable, which I know the industry's really been freaking out about and dying for is serviceability in how these racks are put together. He also went out of his way to talk about there are 6 brand new from the ground up chips. That includes the CPU, that includes the GPU architecture, that includes the Bluefield 4 DPUs, which Ben is a giant fan of DPUs now, which we'll talk about more in the future. That's the co-packaged optic networking switch. So just, I'm leaving a few out, but across the board, the tone that Jensen and co wanted to get out was built from the ground up for new workloads, for AI. Like, this is a step function in architectural change at the rack level, because these are now kind of all brand new chips. And then the kicker, kind of all of it, was we're moving from in NVIDIA's officially endorsing moving from one rack to many racks. So basically the ability to truly cluster these things together, which is where the co-packaged optics or the fiber part of their network switch comes into play. So they can also do these super pods like we know TPUs do, like we know Amazon will do with Trainium 3, and which is the standard for Huawei's Cloud Matrix, which is a gigantic superpod cluster, because it is the only way they can compete with NVIDIA. So top line highlights, more to go into. I'll stop there. I know you paid attention. What was sort of your takes from NVIDIA?
So I'll start with I did not go to the financial analyst event, partly because I had to shorten my trip to CES, but also more relevant, I was not invited to the financial analyst portion. So if anyone from NVIDIA is listening, and I know they are, come on, guys. Second, I think the main thing I took away from all that stuff that you just listed and the way they described it was they are very conscious that Blackwell gave the industry a heartburn when it came to actually installing the systems, right? A couple weeks ago, there were all these photos allegedly of Blackwell sitting unused in a warehouse somewhere, right? And I people spun all kinds of conspiracy theories about what that was. I think that's not unused capacity. That's just things that just takes a long time to get Blackwell systems up and running. It's very hard to change the racks the way they are now. It's just a lot of configuration headaches. And it's clear that NVIDIA learned that lesson and took great pains to to assuage those fears and tell everybody that the next, Vera Rubin is going to be much easier to install, which is, it's good that they're listening. We'll see how it actually plays out in practice. I think the modular stuff is the key, because right now, if you want to reconfigure, you need to fix something in a Blackwell rack. It's painful. You need like a crane almost. So minor, but it does show that they're listening. I do wonder a little bit about why I wonder why they launched it now. Because there are lots of people who've just gotten their Blackwell systems, and now we're talking about Vera Rubin already. It's curious to me that they accelerated the timing. I mean, GTC is only a couple months away, but good for them.
Yeah, and honestly, like that, I mean, like I ran this through my brain, right? There's no structural reason to do it. Like that doesn't change the timing. Sure, they wanted to come out and say, "Hey, we're starting to ramp now," which sounds like a 9-month timeline. So, barring no delays, that's late of this year. They could have done all of that right at GTC the same way. They could have also said, that doesn't affect the timing. I just think they wanted this out there. So anyway, it's interesting. Like I said, it just creates more intrigue around GTC. There was another two things that came out. One from the keynote, and then one other one I discovered after the fact that they're happy to share publicly. They just didn't say that in the keynote. So it doesn't need this can be cooled not with hot water, but basically it can just be cooled with water. It doesn't need a chiller to cool, which I thought was important when you're thinking about, look, it's a lot of building out of brand new, greenfield capacity. And if you need a water chiller and yada, yada, like it's just more expense, right? So there's more optimizations that went into this in terms of, where NVIDIA is looking at this bar, right? In terms of performance per dollar per watt, keeping those costs manageable. And they're trying to not really complicate the entire build cycle, so these can really get installed and up and running quickly. Because he acknowledged as much as anybody, right, which was you want to start making money. You want to monetize this infrastructure as fast as possible. You want to start making money as soon as possible on these tokens that you're going to start monetizing, and so streamlining that is important. The other thing he said that I thought was actually, sorry, he didn't say this. This came out in some of the QAs afterwards. It's very interesting. Is Vera Rubin has a power management system in it that essentially keeps voltage spikes from happening. Yes. So in case you don't know what happens on a training road, and to be honest with you, this point I'm about to make is the fundamental reason why most data center builders do not go off grid, and they stay some form of a grid connection. And it's because when you throw a giant training load, you initialize this training run on infrastructure, the voltage spikes, and it's very hard to manage those voltage spikes without a lot of reliability from a power standpoint. So, for example, if you're moving to batteries, right, or solar, for example, they don't have voltage regulators efficient enough to handle something that's a 25 to or higher percent voltage spike, right, to the load. It's very, very challenging to do that. So it's one of the main reasons people don't go fully behind the meter. That said, now that this rack has this kind of power smoothing, as they stated it, actually means that you can do more reliable behind the meter solutions, whether that's natural gas, battery, probably not solar, but let's just say natural gas and battery, and some combination of that. You can actually do that and manage those volts and not need to have the grid connection as critical as it was before. So if anything, to me, that was like a subtle, hint at this means more people can actually do this behind the meter stuff, where you do have more availability with, elements of smaller gas turbines and batteries, where they didn't before, right? And so maybe this helps time to power, if you will, right? The metric that we talk about. So I thought the power smoothing was interesting, and a lot of people are going to catch on to that as opportunity for more of this move to behind the meter as well. But yeah, I think there's parts of that don't take for granted, right? Exactly like you said, NVIDIA understands the challenges of the industry and is trying to streamline and innovate as much as possible to solve some of these problems that they can go out and solve.
Yeah, and I think the other thing that's going on there is it's not just a question of the meter power, but also power smoothing is a big issue, even for the utilities, because when you're doing a training run, you can see these massive split second swings in voltages as you can imagine as the system is moving and then calculating and moving and then calculating all the bits around the matrix. It the system can go full on and then full off in really small microsecond increments, and that is brutal for the utilities because just nobody is sort of designed for massive swings in such small time increments, and it's a big hassle for even for the utilities, right? It's hard. It's just the utilities weren't built for that. The grid wasn't built for that, and again, this speaks to NVIDIA is just sort of redoing the deployment side of things, making it easier for people to use. And I don't know that it's terribly significant competitively or strategically, but it certainly shows them moving very quickly on the fly and optimizing these things. You think about it, like it takes many years to design a chip, right? They've been designing Vera Rubin for 3 years now, right? Including time to tape it out and all the work that goes into it to getting it into actual silicon. So it's a very long timeline for these chips. But for a rack of servers, you can iterate those much more rapidly, like certainly in increments of months rather than years. And and this is why AMD had to buy ZT Systems, is that they could have that capacity too to design racks and power systems that sort of match the hardware. And NVIDIA's just sort of demonstrating that they already had that capability. I mean, they've been doing it for years, and they're very good at it, and so they're pushing it through. And it also speaks probably a lot to the support they're getting from the ODMs in Taiwan, who can accommodate those kinds of rapid iterations and changing. I'm sure they had a roadmap for server rack designs, and they threw it all out in the middle of Blackwell because they realized they needed to fix something.
Yeah. The other part I thought was interesting was, they're essentially bringing to market or supporting a appliance for, KV cache. Basically he kind of came out and said, hey, memory is a context bottleneck, right? Or context is the bottleneck. And so we can solve that with creative approaches for memory and or storage. And so yes, that is true. But again, that is something that is enabled by their ability to now move to cluster-based systems. The entire NVLink solution, NVIDIA solution, is now soup to nuts, right? Including all of that networking in those racks, which basically means, to me, I think this is kind of the more interesting point, right? If you think about, NVIDIA had verticalized all the solutions within the rack, and now they are starting to verticalize all of these clusters of systems. There's actually a lot of stuff they can add on, right? Once these super pods or things become, it's not just the GPU. It could be more storage. It could be more memory. It could be a whole thing of CPUs, right, sitting on the side if they want. Because again, once you can network these through fiber, it becomes the latency becomes far more minimal, if not negligent, not zero, but negligent. So I think this idea of looking again at the whole system as all of the racks, not just one shelf of the rack or the entire rack, but now all of the racks cobbled together, which is an industry-wide direction we're moving to. So it's not just going to be unique to NVIDIA, but I think just thinking about that kind of system now being the whole thing, all the sum of its parts is just the right way to look at a fundamental level about where they and everybody else is going with these clusters of superpods of GPUs. I don't know what we're going to land on a name on, but either of those superpods, clusters, whatever, a giant set of racks now looking like one compute unit.
Yes. So if you are a company that wants to make a chip that competes with NVIDIA, keep that in mind. Like there's a whole lot of expense and expertise that went into designing the systems, and you're selling against that. Right? AMD knows that. That's why they bought CT. What do all the others do? It's going to get pretty challenging. It already is challenging.
Yeah. Yeah. And that again, I think is kind of a lot of people's takeaway, right? That they will, the lead that others had was because they could, network racks or systems together. NVIDIA is now going to do that. It's going to be very performant, right? With Rubin as a baseline SKU. and they're just going to keep the competition, or keep pressuring the competition as much as possible. And I took a picture of this rack, and I took a picture of the Kyber concept rack, all on Twitter in case anybody wants. But they did not get 3.5 and counting million views like a keyboard computer did.
Yeah.
So the other thing that was interesting, let's talk about autonomy. There was a lot of debate around this, and to be honest with you, this was hotly contested at the QAs I was in, LNS QAs I was in, as well as after the fact and on Twitter about, does this mean that they're trying to give every auto, company the ability to go and compete with Tesla? And there is some of that, right? And there's also whether they're doing this full camera based, whether there's LiDAR options. It wasn't entirely clear. It looks like what they were demonstrating, I think, with Mercedes in a handful of test drives that they gave to some of the media and influencers was not LiDAR based. But anyway, it does feel like, and this is not the first time they've attempted this, right? To say, look, we've got a solution. You can go take it and adopt it. It's an open solution. And now Ford, Mercedes, whoever, name the car company, can have something that can get you to level 2, and beyond as they, move that way. Because essentially they were saying, like, every car will be level 2. And at some point in time, they were like, we believe every car will be level 4. So great. Somebody's got to help get the industry there. And also, to compete with Tesla. So this was interesting. I kind of felt a lot of tension, around this. How good is it? Can you really help the other vendors compete? Do they want to do their own thing? Like, will they work with you as a horizontal vendor here, or do they want to customize? Because there's always that tension in auto. But that was an interesting one. There is upside, right, to be a vendor, but it felt like there was some controversy around the auto stuff as a whole. I don't know if you caught that, but I saw it.
So I didn't catch attention because I wasn't in the room, but I did see all their autonomous vehicle stuff, and I mean, there's this interesting thing taking place in vehicles right now, which is ADAS, right? Whatever we're going to call it, sort of assisted driving, infotainment, digital cockpit systems are very important to all the car companies today, right? And that's sort of the heart of Qualcomm's automotive business, is building those systems. And NVIDIA has had an automotive product line for a long time, but they kind of got ahead of themselves, or they got ahead of the market, right? They were really pushing, their Thor system for autonomy.
Yeah.
And they missed, I don't want to say they missed it, but like the market moved much quicker to ADAS than it did to autonomy. Autonomy's, as we all know, is taking a long time. And so I don't want to say that they missed out, NVIDIA missed out, but they were definitely the market wasn't what they thought it was going to be. And I think they've made some attempts to sort of claw back some of that market, but I don't think they have a new chip exactly for it. My read on this performance from CES was they don't care. Like they see autonomy coming sooner than later, and they're going to push really hard into that. And I'm not going to disagree. I mean, I think there's been a lot of progress in autonomy last year, a lot of momentum there. And I think NVIDIA is just, they have a good platform, and they're enhancing it and building it up. And it's going to, I think it's going to matter a lot, because you saw like Rivian, right? Austin was at the Rivian event, Autonomy. They looked really good with their own silicon. A lot of the Chinese companies have their own autonomy solutions. And I think this is going to fit in really well with that. This is going to be very competitive there, because I think it's going to be very hard. And then big question is, what are the U.S. and European automakers going to do it? Because they're nowhere. They're nowhere in autonomy.
They need something. I mean, that's the key, right? Where's it going to come from? Right. Exactly. Right. So interesting dynamics in competition, which also sort of fed to, well, we're not quite there yet, the theme we talked about in robotics. In fact, and just so that we can all keep track, because I like doing these sorts of things, right? Keeping track of Jensen's predictions. Somebody was like, hey, when are we going to see kind of this mass explosion of capabilities of robots that are very similar, and this is a humanoid robot point, I guess, or maybe even healthcare surgeon robots, you could argue. But basically the question was, when will we see this kind of mass capabilities of robots with human level capables and functionalities? And Jensen basically said he's extremely confident it'll happen this year. So we will see humanoids moving, operating, being able to function with much better human-like qualities, not remote controls. Like I still saw a lot of remote controlled humanoids at this show. So we'll see if that happens this year, but no doubt what I just sort of loosely call said Cambrian explosion of robotics is upon us, and will only continue to grow as there have been major leaps in in foundational models and robotic capabilities that happened over the last 6 to 8 months.
Yeah, yeah. I am more upbeat on autonomy in a while, right? Not least because I now have two autonomous robo taxis to choose from in San Francisco, right? Zoox.
Yeah, yeah,
They were giving rides in Vegas too, so I have Zoox and Waymo.
yeah,
Um, and there's Rivian. There's a lot of I think we're going to see some big advances this year,
yeah.
commercial
Uh,
advances.
all right, let's move on to AMD. There was a very long keynote. Lisa Su had what was officially the first keynote of CES, and obviously doubling down on Helios, right? Acknowledging the moment that we're in with a still giant build out of AI infrastructure. Helios looks good. There was some performance metrics that came out. I also took a picture of the Helios rack that did not go as viral as I had hoped, but it's interesting. I'll tell you, it is fascinating because I had not seen one in person yet. I'd only seen pictures, but it is very wide. It's basically
Yeah,
two racks wide of one rack because they built it, right? Kind of like two racks in terms of its capabilities. I was really surprised, how wide it is, how big it was, which I think is interesting in terms of its compute, but also going back to what we talked about needing to be serviceable, maintainable, movable, right, etc. Which these kind of smaller, slim racks will do. It's an interesting design. I'm not sure if it sticks long term, but their approach, obviously, in kind of doubling up compute in one rack makes sense. But yeah, it was really a lot bigger than I thought it was.
yeah. It's interesting. I actually, when did they first show? They had
I
a
think it was
mock up of the
OCP.
Helios.
It was
Was it
OCP.
OCP?
Yeah.
Yeah. So I spent a lot of time with someone I know who's listening. We were just wondering, like, why is it so big? We asked a bunch of people in the booth, and they didn't really have a good answer. It's noticeably a very wide system. Um, but I don't. I haven't talked to anybody about it. I don't know that that matters, right? I think that
I don't know either. Yeah.
real estate does not seem to be the scarce commodity in this. Space in the data center is not the scarce commodity. It's electricity, and if this has the performance that they're talking about, then
Yeah.
they'll find the space for it.
Well, what makes this approach interesting? Because again, I hadn't appreciated how much it's really two racks worth of components, give or take, right in one unit. Um, it's interesting because if we go back to right scale up and scale out, that if they've got roughly 2x the compute per rack as someone else, and you can cluster 8 to 10 of those right together through either Ethernet and or fiber at some point, that's a great superpod. Like that's a lot of capabilities, right, in a superpod because you're essentially in many ways 2xing right your capabilities per square foot within this one rack. So that like I said, I'll be very interested to see how this takes off and gets traction. Um, but I like the approach. We talked to a bunch of folks, kind of in the AI spot. I think a lot of folks are optimistic that this will do well for AMD. That the performance per dollar per watt will hunt, which again is the metric that Jensen wanted to use, or that I think we need to track for everybody. Get the most out of your wattage, especially when we're wattage constrained. Make the most money within your wattage budget. That's going to be a bar, and it does look like AMD's going to be competitive there. And then to just completely add to the excitement, they teased, I guess, the MI 500. Didn't sort of showed its performance increase over the 450 or the MI 400 series, which looked to be significant. So AMD again, my take from that was they're just saying we're not standing still. They're obviously engaging with customers because at the QA, NVIDIA sort of said the same thing, like we're already talking about orders for 2027 with customers. So they're already booking out that long. I imagine AMD is similarly doing that because, again, if you're building a data center, if you're planning a data center right now and you're going to deploy it in 27 or whatnot, you're going to talk to the vendors about what they're going to be releasing in 27. So you can plan for that infrastructure. But yeah, they kind of announced slash teased MI500, which looks great. I was not expecting that, to be honest with you. But again, I think it just goes back to we're not standing still. We're going to stay in an annual cadence. We're going to keep bringing out these new products that solve problems, et cetera, et cetera, which is, again, what I think a lot of people are interested in, that they can keep their cadence and keep delivering on time.
Yeah, I mean, I don't think anyone doubts AMD's ability to execute to roadmap, which is a big statement because you think about 10 years back, nobody would have said that. It was the opposite. But now I think we're all confident that if Lisa says this is the roadmap, they're going to hit the roadmap. And as we learn more about the specs of AMD system, certainly MI500 looks incredibly competitive with what would be Feynman from NVIDIA at that time frame, right? Very, very competitive. I think they'll have closed the gap entirely on performance, just sort of raw performance. And they have a good system in Helios. They're probably going to go through the same growing pains that NVIDIA encountered with Blackwell. So that's a little bit of a concern out there, but they look very good. And to your point, yeah, I mean they're planning these things out years in advance. I mean, just even before AI, you would plan out data center based build outs based on everybody's roadmaps. Intel and AMD would take their CPU roadmaps to the hyperscalers 2-3 years in advance. There'd be constant conversations about that. And then as we get closer, they'd sort of finalize the orders. But now in AI, where everything is so scarce and the numbers are so big, I'm sure they have. I'm sure the sort of big 6 or 7 AI foundation infrastructure builders have 5-year roadmaps. I mean, you have to. You're paying for all that power, so you gotta have everything sort of lined up and know when things are coming on stream.
Yep. Yeah. Exactly. It's interesting that there is, at least right from AMD, they still also talked about client PCs, which we'll talk about also with Intel in a moment. But it was, again, largely data center driven, AI infrastructure driven. There is a client portion of this, which we don't want to discount, but the reality is that there's just so much demand and upside for AI infrastructure that it doesn't surprise me that was a big portion of the conversation. But I agree with you. I think we do expect and anticipate, right, AMD's execution to be good. You're going to see demand come from them from a wide range of sources who either cannot single source from NVIDIA or don't want to increase the ecosystem. But it's all compute hands on deck when you're compute constrained. And in this case, right, this benefits AMD. So yeah, there was a good talk there, and a lot of good content, or a lot of good conversations around AMD at the show.
Well, I mean, I personally think part of the reason that NVIDIA moved up the announcement of Vera Rubin is because I see these two companies, AMD and NVIDIA, are both fighting for airtime, right? I don't think NVIDIA had a very rough November, December in terms of its sort of the story out there in the market and in the media. And it's New Year, it's CES, it's a big event. I don't think NVIDIA, I don't think Jensen specifically wanted the headlines out of CES to be AMD's MI500, right? And here we are, we're talking about both of them in the same breath. And I think if they hadn't talked about Vera Rubin at the show, it would have been much harder for them to capture attention. You and I would have had stuff to talk about what they would say, but in terms of like just raw headlines and getting the being in the out in the part of the story, I think that kind of concern drove a lot of what was going on with timing on some of their announcements.
Yeah, agreed. All right, let's jump to Intel. It was a little bit more of kind of a muted event, but obviously a couple of things happened. As CES always is, there's a lot of laptops that get shown. It's been a while since, to be honest with you, maybe this was just me because I saw a lot of Intel coverage, but it felt like a lot of people were very happy with the laptops that were coming out. There's a lot of really good ones, to be honest with you. Like, I looked at all the vendors, designs, and I feel like you can say this every year. In fact, I know you can say this every year, but this is the best crop of designed laptops we've seen, with the caveat of a lot of really aggressive price points. Like, you're going to see some really good laptops, sub 800, all day battery life, OLED or very high, LCD displays, capabilities, right? A lot of compute capabilities, can do AI, et cetera. Thin and light, right? Full milled chassis. It's extremely interesting. In fact, my favorite announcement, and I say because I was very mad at this decision by Dell to kill the XPS brand, was that the XPS brand has returned. And man, and they made some really good laptops, Panther Lake based. So, but it felt like the energy around Panther Lake is quite good. Like, performance per watt is there, battery is good. Again, Intel has a platform that can scale from the low end all the way to the high end, and that's just been a failure of their architecture product, to be honest with you, the last few years. So it felt like there was a lot of energy, a lot of excitement behind Panther Lake and behind Intel. So I do think they're going to have a good year on client in particular. We can talk a little bit about the data center CPU stuff, which I think is a fascinating other trend. But yeah, the energy was there. The OEMs seem to be very happy with Intel for Panther Lake. Very really committed. In fact, more so committed to Intel than I've heard in a long time from their commentary. So, could be a good year for client with Intel. But like I said, good product, and got a lot of good coverage.
Yeah, I think Intel, again, judging from the outside, Intel came across much better than they have in a long time across everything. I mean, we not at CES, but sort of in the weeks before, there's a lot of news about them on the packaging, winning packaging deals for Intel Foundry. Lots of talk about new customers for Intel Foundry. Nobody's out there saying anything bad about 18AP. Lip-Bu even sounds positive about 14A. So a lot of good news coming out of Intel right now.
Yeah,
and they seem to be doing some things much better.
Yeah, I mean, and most people probably saw the president as well as Lutnick did some stuff with Intel. We're very happy. Seem to be like committed to this idea that we need to make sure we have the best leading edge processes in the United States on United States soil by United States companies. It's hard to walk away from all of that and not think 14A is going forward. But you're right. I think we've talked about this before. Everybody was just wanted to make sure Intel was going to be on time and deliver a good product with 18AP with the first, right. And that was just, and they did it. Like, I think the industry commentary is overwhelmingly they've accomplished those two things. Yep. So great. Going forward, every year, in my opinion, is still a prove it, scenario until they've done this long enough that you're not going to question anymore. So Nova Lake, same thing. It's going to need to be good. It's going to need to be on time. It's going to need to fit gaps of the portfolio. It's going to need to be, a quality product across every one of the SKUs. So good start. We need this to continue. We need this trend of dependability and performance, credibility, and all of these things to continue with Intel. But the thing we were all wanting to see, a great, 18A product that delivers performance per watt and on time happened. So very, 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 very good. But for Intel, obviously this was very like client heavy. Like, you just didn't hear a lot from other, vendors as client heavy as a story, because this was really the thing Intel wanted to get out right around Panther Lake. So,
well, and you're right. I mean, think about even a year ago. What you said that matters the most is what the OEMs are doing, right? You've had lots of OEM conversations. They seem pretty happy with Panther Lake. That's the headline. That's what matters most for Intel right now. They got that working. It's a good chip. We sort of suspected that. We talked about this 3 months ago, but it's clear Panther Lake is looking good. That keeps their customers, the OEMs, happy. And I think that's what's critical for them to sort of get through the next few years, is having product working for the first time that I can, in a few years. right? And then not for nothing, there are a lot of interesting form factors out there, right? We talked about the HP keyboard all in one, um, which again I'm oddly obsessed with. But then there's also like I think it was a Zeus had this sort of retractable screen, the sort of the screen group. Lenovo, was that Lenovo or Zeus? I can't remember. My point is that the OEMs are sort of doing interesting things with form factors. So that's
Yeah,
Intel's looking pretty good now.
yeah, yeah. Agreed. All right, let's just briefly hit on the CPU story, and I say this because we're going to circle back to something that Jensen said in both QAs. He, for whatever reason, felt the need to talk up CPUs because obviously, NVIDIA makes a lot of CPUs. But to go out of his way to talk about the design not just of Vera Rubin, the Vera CPU, but also the Bluefield CPU. So that's I believe an 88 core ARM CPU, custom designed again by NVIDIA, that runs their DPUs. And DPUs, as I think you all have heard me say before, is an increasing number of DPUs per rack. So it's not just one per rack; it's many and growing. And that complexity will come up for a digital processor that basically manages orchestration levels of AI workflows across the stack. Will require more as we move to these kind of superpod clusters. But he kind of went out and said, hey, I wouldn't be surprised, and this is literally his words, I would not be surprised at some point we're the largest CPU vendor. And that then kicked off a whole conversation around like, ooh, maybe that's really good for Intel, or obviously that's good for AMD because now they're going to sell more host CPUs. There was also a whole thing, oh, that's great for ARM because there's going to be more ARM based CPUs out there because your Amazon and Google and Microsoft, anybody making an accelerator also probably has to make more CPUs and DPUs. So this just, I think, kicked off an interesting addition to kind of our discussions, which was, I don't know, maybe a year ago or before, I think our standard assumption was the ratio of CPUs goes down. Like, this is not going to be a market that grows. And now everybody's like, oh yeah, of course it's going to grow. Like, you're just going to need a whole lot more CPUs for all of this. So things change, yes. But I think the role of the CPU is really the thing that gets interesting, right? And Jensen made this point, and it's in line with everything we had said before around like, well, why would the number of CPUs go down? Because you're doing more on the GPU. You're still doing more on the GPU, and this is sort of Jensen's point, which is that the workloads are moving from the CPU to the GPU, but these CPUs are needed to help manage and orchestrate the whole process. And because of that, as complexity grows, you might need more of them. Their roles a little bit different. Maybe CPU vendors don't need to chase performance the same way. You just need to be more efficient. Same cores, more efficiency. I think that's a reasonable thing to conclude on as well. So just the nature of it's changed, but again, I just think there's going to be opportunity for CPU vendors is the point I'm getting to because of these changing dynamics. Just again, they're not the primary compute, architecture for these workloads going forward.
I I spent a lot of time on the I spent all my time on the floor this year, and the number of conversations I had about AI at the edge was off the charts, right? And I mean, and I'll admit that like those conversations are not new. I've been hearing about AI at the edge for many years now, and I tend to I've in the past I've usually discounted it because it's mostly the PC vendors talking about AI at the edge, which hasn't played out yet. But I do think that there's a growing understanding in the industry of what actually needs to be done at the edge for AI. And I know I'm a little bit off your point, but what I'm getting at here is for the first time since this all started in 22, I feel like there's actual products being planned or use cases being understood where you need more things being done on your own personal devices that you actually want to do
Sure.
with your you don't want to send all your stuff to the cloud. We're starting to understand what gets sent to the cloud, what gets done locally. There's that real understanding there, which I think bodes very well for ultimately actually needing AI CPUs and AI, and or AI is going to get done on your device, which is going to be really good for the CPUs because a lot of it's going to be on PCs. And I think we're finally starting to understand what those use cases are and what's needed. So I think there's a very strong CPU story emerging. It's still, you know, still a little bit ways to go, but we're starting to understand that. And so I could definitely see like next year's CES having some interesting applications run on CPU on PCs, right? And I think that's critical. And I'm with you. I mean, I saw a ton of coverage of different aspects of cloud AI and what the CPU is going to do there. That story is becoming. It's probably the NVIDIA PR machine behind it, but they're not wrong. Like I think there is a lot of importance for the CPU in the data center, right? And not for nothing. Like I think we talked about this when ARM reported earnings. They actually acquired a memory management chip maker, Dream Big, right? And
Dream big, yeah.
Right, Dream Big. And they didn't talk about it much. I was giving them a hard time about it because they should have talked it up because what's I think going to take place is the CPU, the data center CPU is going to change. It's going to need to do new things, and I absolutely think. I mean, I think Dream Big is really important for ARM's CPU story because I think it shows that they're investing in whatever the sort of I don't even know how to define it yet, but the nature of a data center CPU is gonna evolve and become more capable. And so today, like the knock on CPUs in a sort of GPU cluster is that it's just a very advanced memory controller. It's an expensive
Right.
memory controller.
Right.
And I think well, okay, if that's I mean there's a kernel of truth to that. It's more than that, but there's a kernel of truth to that. That's fine. Let's design a CPU that's incredibly efficient at doing those things.
Yep.
That's
Yep.
all within the realm of possible. So
Yep. Yep. And that I think is at least where I'm at right now is the dynamics for how you think about the CPU is just changed. So there's still gonna be a lot of them. We're still gonna need everybody to make them, but yes, the roadmap is gonna look a little bit different, and there's nothing wrong with that. I think that's perfectly fine. Sub theme of the show, which is not a secret to anybody, really, if you track this space, but this memory problem is going to persist for a long time, man. Like, dude, everybody I talk to, it's rough waters out there. getting memory. Now, again, just to go back to, we spent episodes on this, but just to again lay the groundwork for why and really some of the structural dynamics that we're going to watch. The memory industry has just historically been very, very cyclical. And what means by that is that this is the type of product that, and storage, I'm throwing storage into this too. This is the type of product that you can buy in bulk if you're any name number of people and keep it in inventory and use it as you need, which is why the memory industry will say we're going through a period of digestion. We've built a lot, people bought a lot, we had 3 or 4 great quarters, and now we gotta wait, right, for them to digest through that before they buy more. And that has just historically been why people do not love investing in memory. Now, a lot has changed. There are truths to that cyclicality that will come back. But then there's also dynamics for HBM, for example, that are actually a lot more than like logic because they are being built into chips that are being shipped in real time. And so you're not sitting necessarily on inventory of HBM. You're more likely, ordering as you need and then building and shipping it to TSMC, and it's going into an accelerator, and then it's being shipped. But because of this dynamic, the memory industry doesn't build out foundries, right, at an exponential rate because they don't want to sit there unused. So they probably more than anybody try to balance what they believe is their supply to demand in terms of manufacturing. And the bottom line is there's so much demand they can't meet it, and they're just not probably going to go buy, as we've talked about before, or start making two or three more foundries because everybody's afraid of cyclicality. So it makes for an interesting discussion as to how some of this gets solved, but it doesn't take away from the moment that we're in and the reality that like everybody's basically saying, we're already talking about post 2027 of vendors locking up capacity in memory and storage. It's supply constrained for the foreseeable future, and there's almost nothing that's going to change about that in the short term.
Yes. Um, I'm gonna focus on the client side a bit of this, because a big source of tension I picked up, not least at home with my hobbyist 13-year-old, is right at the end of the year, Micron announced that they were exiting consumer flash NAND, right? And I like the number of people I heard talking about that at the show this week was much bigger than what I thought. It's right. They haven't really abandoned the market entirely. They've just sort of given up their own brand for it, Corsair. But it's clear that they are all the memory makers are now facing this sort of this enviable position that it's a good problem to have, which is they have so much demand that they have to allocate between enterprise AI and consumer, and the prices for AI stuff is so high, that it doesn't, like, if you have a fixed amount of capacity. What are you going to do? You're gonna sell $100 consumer parts. You're gonna sell $10,000 of HBM. It's not a perfect comparison, but you take my point. There's a limited amount of capacity. You might as well go for
Yep.
the best margins, best prices.
I
And
mean, again, I don't blame them. Like anybody, you don't blame them from saying like, hey, that's the way for capacity we're going to bet on. Like
yeah,
that's again, and Micron does not have the capacity of SK Hynix and to some degree Samsung either, right? Just in terms of ability to manufacture, so they had to make decisions. So
yeah,
go with the margin, right?
yeah,
But right, that just leads more to, well, that just means we're still going to have more flash constraints and DRAM and
everywhere,
a whole slew of other
everywhere.
things, right? In fact,
Hard drives.
I started joking with, despite the cost uh, point I'm about to make, I started joking with OEMs. I was like, hey, are we going to need to bring back, little SD card storage spots, and or let me put NVMe somewhere on a machine because I need more memory on it because you can only ship me 8 or 16 in a reasonable price. Yeah, it's something. So all of that to say, the memory run continues. In fact, I was in Micron's suite and they had a nice little, I tweeted this, but a nice little glass kind of covered showcase of HBM and a whole bunch of other RAM. And I was like, I'm just gonna smash and grab. There's like $1 trillion of things, right? Just memory sitting right here. I'm gonna break it and run out the door.
I mean, I heard from 3 different people. They were at a party the night before. There was someone from Micron or Hynix at the party, and they kept telling people, "Sorry, I don't have any memory for you," like
Yeah.
in their pocket, right?
Right. Yeah. Yeah. Pull
If
out the
you if you
suit.
work
Want to
if you
stick a
work at a
memory?
memory company, I guarantee you're telling that joke every day.
Yep. Yep. Want to open up the coat? Stick a memory. Stick a memory.
Sorry, I have no samples for you. Sorry.
Oh, the insanity of it all.
Yeah.
All right. Yeah. Any other sort of last themes? Like I said, we saw robots of all kind, lots of just connected IoT stuff that's now AI enabled. Uh,
I mean, I noticed one thing is the everything that used to be called smart is now called AI, right?
right.
Smart home, smart lock,
Right.
those are all AI locks. AI. It's the same product, but it's now called AI. So that was a little dull. But I do think the much more exciting was the number of robots. Like, I don't know how many. I lost count. I saw a dozen companies selling lawnmower robots, which I'm not calling. I'm now calling them mobots.
Mobots.
Everybody had a mobot. And they do a cool thing. I mean, they go up hills, and somebody had a thing where they're like all the mobots were doing a little dance. I mean, it was just fantastic. Um, I don't know when we're gonna get humanoid robots. Like, that is still, like, I didn't see a really good humanoid robot, but I saw a lot of good parts of humanoid robots. Like, I was joking before about hands. The dexterity they've gotten on the hands now is pretty impressive.
Yeah.
Right, and there have been a lot of videos in the last few weeks about Chinese robots at rock concerts dancing. I mean, I think for me the
Fighting in
most
rings.
fighting in rings. To me, the most interesting keynote was the Boston Dynamics Google Hyundai event. They had a keynote on the first day. that was pretty compelling. Like they now have a Boston Robotics now has a laboring robot. It's pretty good. But again, we still have a ways to go. Like the other thing I heard a lot about was the robot that was dealing cards. Right, we're in Vegas, so they have to have a card dealing robot hand, and it was very slow. It was either very slow or it had tremors. But it was able to pick up a single card. So
okay,
like we're getting there. It's just we got a little ways to go.
Yeah,
right.
Yeah, but for all the watchers, what this intrigues me with is like this is like one of those things that we're cataloging because year over year it'll be really interesting to see how much more advanced they get and then how many more of them show up. In fact, one of the things I saw, like I used to do this with Benedict Evans, our guest from a few weeks ago, regularly, where we would just go walk the like backdoor corridors of the Shenzhen and Guangdong ecosystem and just see what people are mass producing.
Yeah.
And this year is just a bunch of smart rings everywhere, right? Smart appliances, like you said. But the one that I thought was interesting was exoskeletons were everywhere. So those little robotic things that you put on your hips. And I had a conversation with one of my friends in supply chain. He was like, do you know what they're doing? Every single one of those coming from a Chinese company is capturing data to train humanoid robots.
Yeah. Yeah.
Buy a exoskeleton to help you walk. And oh, by the way, you're going to help us train our robots to walk while you do it.
I had a conversation with somebody who's doing AI research, and we were debating. We didn't come down on anything, but the debate was there's all of these companies now that are training robots either with operators or with, like you said, like sort of by hook and by crook.
Yep.
Methods. Because like with autonomous vehicles, you put all the systems on a car, you drive around, and that's how you train it, right? The debate that I think is now taking place in a lot of robotic circles is, do you need that, or can we get to the point where LLMs or some other variant of some other model is good enough that you can build a world model that generalizes and can actually sort of remove the need for all of those, for all that training. And I think that's what we're going to end up with. Is there going to be some companies, a bunch of companies, probably in China, will come up with these sort of elaborately trained robots, and just as those start to get commercial, somebody will unveil a truly generalized robotics model that eliminates the need for that.
Yeah,
all that training, and suddenly anybody who can get access to that model can then build a robot.
Yep.
Right. We should have a robotic show later this year, and we talk about because not just the models, but also all the components. Like, oh my goodness, so many.
Yeah.
Many things.
Yes. Agreed. All right. Good CES recap of all the things. Thanks for listening, everybody. Thanks for kicking off your new year with us, and many more episodes. This, I think, is our 4th year of the circuit. If I am,
we're coming up on an anniversary. We're coming up on an anniversary, so
this was it. So thanks for listening, everybody, and we will talk to you next week.
Thank you, everybody. Tell your friends, click like and subscribe, and all that.